In this video, I want to talk about barrel shifters, what they are, how they work. And your lab is based on this particular idea. You're going to expand on it and build larger barrel shifters and a little bit more versatile barrel shifters. But what I want you to remember is the following. A barrel shifter is just a combinational circuit. Even though it's called a shifter, it's not actually a shift register. There are no registers involved. There are no memory elements in here. What it has an input, and that input is A, which is 8-bit in this case, and it gives me an output with the same number of bits, which is 8 in this particular case. Okay, so I have an input A and an output Y. And I can shift it, and it's a cyclical shift, basically. It's a rotational shift or a cyclical shift. That's why it's called a barrel shifter. Okay, by a certain amount, and this amount here is 3 bits, and 3 bits because I have 8 bits, so log base 2 of 8 is actually 3, okay? All right, so I'm going to start with an example, and I'm going to start with the 1 because the 0 is silly, as you're going to see shortly. Okay, so I have an input that way, and I have this is the output, and the amount of shift I have is 1. So let me show you what's happening. What's happening is really the following. I'm doing a right shift, so let me just write this in here. So I'm doing a right shift to that particular side. So what happens is this 0 gets in here, and because it's on the least significant bit, it gets pushed and put at the very front or at the most significant bit. So that particular 0 gets shifted here. That's why it's called a cyclical, because it actually goes back to the most significant bit. Okay, so what happens then is this particular 1 becomes the least significant bit, and so forth, and you get the idea. It's like everything got shifted by 1, and the least significant bit became the most significant bit. It just happened to be that this barrel shifter is actually shifting to the right. Okay, there are other barrel shifters, as you can see in the lab, that basically can shift to the opposite direction. But for the sake of consistency, you can actually see it's basically the A is still stable here, but what you can see is the output is a little bit shifted by a different location. So let's see what happens in here. So in here, I'm going to take this particular 0 and I'm basically shifting it by 4 locations. So it's actually going back to the most significant bit, and then 1, 2, and 3, and 4. And I'm going to see that this is particularly that 0. Okay, the one that actually follows it, which is 1 here, you're going to see that it's here and so forth. You get the idea. So the reason why I didn't cover 0 is because a 0 shift is basically the input is the same as the output. And again, there are no memory element. So the minute you actually cancel whatever is on the input of the barrel shifter, the output will be canceled. It's not just gonna stay. It just shifts whatever is on its input. It's a sequential circuit. Of course, you can see in the 7 is basically, it's actually really interesting. It looks exactly the same as the beginning. All right, because I shifted by 7 locations. Or actually it doesn't, it shouldn't, because I should look and shift by 8 locations. So it's shifted by 1 location, basically, more or less. So you get the idea. All right, so that's good. So that's how a barrel shifter is. So let's see the code for the barrel shifter. Okay, so the code for the barrel shifter, again, I want you to think about black boxes here when you think about inputs and outputs. So think about it in here. I have an input and another input. So these are the two inputs in here. One is an 8-bit, the other one is a 3 bits. And I have an output that's also an, like 8-bit. This is the output. You see, it's pretty simple to think about. And then here, what I have is I implemented it with a case statement. That means I use a multiplexing routing network. Okay, even though it looks large, but that's fine. That's a multiplexer that's basically its selector is 3, so it has an 8 input and an 8 and a single output and whatnot. All right, so that's good. Good. So this is the implementation for it. It's pretty straightforward. There's nothing about it. Like, I'm basically using concatenation operators in here. Okay, so I'm basically taking part of the A and concatenating to the others. So you get the idea. Like, read it. It's not real difficult. And of course, you can see that I put the default in here just so that I'm sure that I assigned Y all the time and I captured any case whatsoever, so that I don't have any memory elements here. This is a combinational circuit. Good. So what if I told you my A has changed and it's no longer 8 bits? I want to build a barrel shifter, and that barrel shifter has to be more than 8 bits. Let's say 100 bits. If it's 100 bits, you're going to actually have to do a lot of cases and count for all of them. Chances are you're going to make mistakes and your code is not going to be scalable. Okay? So what you're going to be doing in the lab is actually you're going to make this parameterized. So you're going to actually change it between basically whatever number I give you, you can be able to build it. You're going to build some sort of a template, a parameterized template, and that template will be expanded. It's going to be scalable, basically. You're going to be building scalable code. This definitely is not scalable code, and you're going to change it. So how can I make this scalable? Well, I need some sort of an algorithm. So here's the algorithm for a barrel shifter. This is a very famous algorithm, okay? So I'm gonna explain it to you with an example. I find it easier. Here's everything is written here, but I'll also write it like step by step so that you can follow. So it tells me is you're gonna have to divide the process into shifting stages, okay? All right, so I'm gonna shift in stages. I'm not gonna just shift them all. This is an algorithm, so it's a step by step, okay? So how many stages do I need? Well, the number of stages, n, okay, that's the number of stage, is the number of bits for amount. In this particular case, in this particular example, it just happened to be 3. So I need 3 stages, okay? So I have stage 0, stage 1, and stage 2. I have 3 stages. At the very end of these stages, I will have my full barrel shift done, basically. So at each stage, what you do is you're going to either shift by 0 or 2 to the stage number. So let me just show you here. So we're going to do with this example. You don't have to look at the table. The table actually is what we're going to do. But here, anyway. So what I have is I have this here is the least significant bit is 1. Then comes a 0 and then comes a 1. Okay, so my very first shift stage, I'm going to just take a look at this one in here. So let me just highlight it. So I'm going to take a look at this particular one. So this particular, since it's a 1, okay, at each stage, I either shift by 0 or 2 to the stage number. Since it's not a 0, I need to do a shift. And then the amount of shift I need to do is 2 to the stage number. And this stage is stage 0, so I need to shift by 1. Okay, so I need to shift by 1. Shifting by 1, and let's keep it that we're doing a right shift like before. So I need to shift this particular case here. It becomes 1, 0, 0, 1, underscore 0, 1, 1, and then 0. Basically, I've shifted that 0 in here, and that's what you see in here. Okay, good. So I have that value now. So I'm going to keep it. And now I don't need A anymore. Okay, what I need to do is I need to go to the next stage in the shift. And the next stage in the shift, what's it doing really is actually I'm going to the shift amount, the second shift amount, and I'm shifting it here, and just happen to be 0. And because it's 0, what this rule tells me at each stage you either shift by 0 or the 2 to the stage number. That basically tells it's based on the value and the amount, the bits. Just because it's 0, I don't need to do any shift. My shift is by 0, so I'm going to move to the next step. So the next stage, which is the last, is actually here. I'm in stage 2. I need to shift because I have a 1 in here. But what is my amount of shift? Well, my amount of shift is 2 to the power 2, which is 4. That means I need to shift this particular guy by 4 location. Okay? So how can I shift it by 4 location? Well, I need to do this here. It will go to 1, 2, and 3, and 4. Okay, so it's going to be 1, and then becomes a 0, then becomes a 0, then becomes a 1, and I believe that becomes here a 0, 1, 1, 0. So, and if you take a look at it, this is exactly what we got a few minutes ago in here when I actually asked you to do that for what it's like we did that. This is the value that we got, which is 1001, 0110. And that's what we got in here, 1001, 0110. And there's basically an algorithm that will allow you to make your code a little bit scalable. Okay, so I'm going to show you the code for it, and that's basically how the code looks. Okay, the code, again, it just goes in here. You can see it. It goes through it but one by one, and the amount of rotation. So the last step is just confirming what I just did step by step. The amount of rotation is basically you're going to take the value, which is M0, okay, M1, M2. This is basically what we had as a 1, 0, 1. And you multiply by either, well, we shifted by 1 location. We didn't have to shift by 2 locations. We had to shift by 4 locations. If I had a 1, 1, 1, which is 7, I would have had to shift by 2 locations in here. So you shift sequentially. Okay, so the code that actually captures this particular algorithm is in here, and you can see that basically, like you can go through it. I'm using basically the question mark, basically the if statement. It's a conditional basically operator, and I'm asking is the amount 0, 1 or 0. If it's 1, I'm doing that particular shift. It's 0, I'm keeping it, and then I'm taking that S0, and now I'm shifting the S0 in the next stage. Then the next stage I'm asking is the amount 0 or 1. If it's a 0, you're going to keep it as is. If it's 1, you're going to actually do some sort of a shift. And these concatenations are calculated based on the 2 to the, like here it's a 1 bit. Here's, you're going to see it's a couple of bit location, and the same goes in here. I'm going to take that S1, I'm going to shift it by 4 location, or I'm going to keep it based on that. And you can see it. So this is basically the test bench for what's happening, and you can actually just follow it, or the output of the test bench. I'm not writing the test bench in here yet. We're not going through test benches today. Okay,